Okay, back due to popular demand, this time we have the 2016 question 1, which is the orthographic projection question from 2016 section B. Again, with all the higher level orthographic questions, you have 3 parts. You'll have to do your 3 orthographic views, your front elevation, your end view and your plan. As well as that, we'll have a freehand curve, which you can see here is most likely going to be that one there. We'll have to do that. And then the final part will be a surface S, which is a simple rebatment to surface S to get a parallel with the X, Y and plan to project up. So as always, the first thing we do is read the question thoroughly. A pictorial view of an MP3 music system is shown. Also shown is a 3D graphic. There's a 3D graphic of the music system. Draw an elevation in the direction of arrow A. So our front elevation is looking in here in the direction of arrow A. Project a plan from the elevation, which of course will be directly underneath. The plan will be directly underneath our elevation as always. And then project an end view in the direction of arrow B. Now again, the end view is all relative to our elevation. So our elevation is here looking in front of the arrow, looking in the direction of arrow A. And as we look at the front of the MP3 player, the arrow comes from the right hand side. So when it comes from the right hand side, we'll be projecting that view over onto the left hand side. So that means that our elevation and plan will be kept onto the right hand side of the sheet here. Now, when we work it out, we'll do the usual. We'll do the box, the whole elevation fits into the whole plan, and finally then the whole end view. So to start off, we'll zoom out our sheet. And we'll put a light line across the middle of the sheet. That'll be our ground line. Thank you. Then, now, with our elevation, okay, looking in the direction of arrow A, what's the width of the object? The width of it is 240 mil. You see it here at the back. Okay, it's 240 wide, and that's out to the furthest most right point and out to the furthest most left. So it's 240 wide altogether, and the height of it is 110 millimeters from the bottom. Right, there's no surface below this. Right up to the top is 110. So 110 high, 240 wide. So I'll come out there and I'll mark 240 here, which is quite long. There's our 240, and then our 110 high, as we said, 110 mil high. So will be here. Okay, so that's 110 mil. Now bring this across. That will be the height of my elevation and of my end view, of course. So I'll bring that across the whole ways, and then this will be the left hand side of my elevation, and this here will be the right hand side of my elevation. Now, okay, so I'm going to zoom in specifically on the elevation now, because in the last video, the feedback I got from you guys is that it kept zoomed out a bit and it was hard for you to see. So we've zoomed right in close here. Now, in our elevation, we'll say how many surfaces are we going to see. As we look in, we'll see this bottom rectangle, 1, that side 2, the other side 3. We'll count the 2 of these as 1, 4. We won't see that surface because it's a horizontal surface. We'll see all the shaded one there, 5, and we'll see that one 6. Now what heights am I looking at? Well, in the centre, it'll be 12 high for the rectangle, then another 18 high to the top here, so it'll be 30, 80, or 12 and 30 high in the centre. So what I'll do is, first of all, I'll mark my middle point. Okay. Now, will I actually have a line drawn down the middle? I won't, but it's handy to have because I'll have to go out either side of the middle. So if there's my 240, then 120 is my centre line. Okay, so I'll bring that up lightly. Okay. Now, then we have how far either side. Okay, well, it's 62 for the rectangle altogether. So of course, half of 62 is 31. So we'll be going 31 either side. So I'll put 31 on the point. I'll mark back at 0, and then I'll mark at 62. Right? That's for the little rectangle. Then we have another 22 and 22. So altogether we have 106. Half of 106 is 53. I'll put 53 there, and I'll mark 0, and I'll mark 106. Okay? I'm going a bit quicker again in this one, lads, because he said in the last one it was a bit slow. Okay? Now I'm going to bring them up lightly. Now how high did we say we went up? Well, the first one is up 12 and the second one is up 30. So as I mark here, I'm going to mark up 12 will be the first height. Okay. Sorry, no, you can see that there. So 12 will be my first height and 30 will be the next height. Okay. And I bring them out either side likely. So that one and that one. Okay. Now, first rectangle is this front one here. Okay, so I can heavy that in. Now, actually, all the base will be heavy, we know, right? We'll have the curve, this line, that line, the line there, and the curve. So I'll put the whole base in heavy there now. Okay, we'll start to heavy this. So that will go heavy there to there. The left hand side will go heavy up to the top. So we'll go heavy here. 12, and this one will go heavy there. And then there we have a horizontal line here, and we'll have a horizontal line there. So here's one, and here's the other. Okay. Now, so that's up 12 and up 18. Then from there, that's shine back to there, and from there, that's shine back to there. Because as we look in, we see this point, which is there, going back there. We see that point going back to that one. So I'll join them, not at any specific angle. So it's just simple case of joining them back like that. Okay, that's that part of it. So now we're going to see two other parts. We're going to see all the shaded area of the MP3 player, which is this surface here, and then we're going to see this white surface here with a freehand curve. Now, I know that this goes out to the bottom there, and then it goes to a point that's in a set distance. Okay. Now we have to work out how far up here in the top right hand corner am I going to come in and join that up to, and how far there on the left hand side am I going to come in and join that up to. How do I work that out? Well, first of all, this quadrant here is radius 67. So that means from there into this point, which is the center, is 67. But when I come up, that's not the point that I'm joined to. That's that point there. So when I come in 67, I'd have to come back out of it. And that, how far I come back out is this radius here, which I don't have here. But if you look over at the other side, we're given it as 15. So 67 minus 15 is 55. So I'll come in 55 up here, the top right hand corner, and I'll come in 55 over here from the top left hand corner. And those points now can be joined down to the bottom corners. So okay. Now, as regards this surface here, okay, do we see much of it? Well, we see there's 2 points there, right? How far are they? Well, if you see, now this is careful, you've got to be very careful here. This line comes out from the center, right? This obviously a semicircular line comes out from the center, arrowhead radius 30. So when I go 30 to the left there and 30 to the right, that will give me them 2 points. So I get my center line, that's why I put my center line in, and I mark 30 degrees to the left, and I mark 30 degrees to the right. Now there's going to be a freehand curve here which I don't have yet, but it is important to note that I have them 2 points. Okay. Now that's as much as the elevation that I can draw at the moment, right? Of course, in this surface here there's a little rectangle, right? And I know that the sides of it are straight up from there on the left and straight up from there on the right. So I'll do that now lightly, but I can't do any more. The 10 mil that it gives you on the sheet, where are we going to see that view? Are we going to see that in the elevation? No. When we see this surface here, all this surface as an edge view or as a line, then we'll be able to measure up 10 and measure down 10 and draw them in, and we'll get our heights then. And that's obviously going to come from our end view over the left hand side. Now, we've done as much as part A as we can, right? Or as we're going to for the moment. Project a plan. So as always, the plan is projected directly underneath. Okay? So we'll zoom out now a bit, and I'm going to project down my widths. Okay? So again, we get how much, right? the overall size, the overall width of any object from the front and the above are the exact same. It doesn't get any wider when you go up above and looking down at it, and it doesn't get any thinner. So it's the same width down. Now, as usual, we leave a nominal distance about 15 mil between the plan and the elevation. Okay, now that's the back of it. So as we look in it, the back is here, right? As we're looking down on top of it. What's the distance from the back to the front? Well, if we come out to the side here, it's 67. We go back plus 40. So it's 107 mil. So from the back there to the front is 107 millimeters. So I get my set square and I mark out 107. So that's 110 there, right? So I'll just move it up another 3 mil. That's 107. Mark 0 there. Draw this light line. Okay, so this is the rectangle that my plan is going to fit into. And again, how many surfaces do we see on the plan? Well, we see all this part up there, the white at the top, the bit that's sunk in it. We'll see a lot of this shaded figure here. We'll see all of that figure. We'll see this surface here, right? Now, is the back heavy the whole ways across? It is. It's 3 lines that we'll see. It'll be represented as one. From here to underneath this point, it'll be rising up towards us. Then it'll be a flat horizontal line, so we'll see its true length, and then it drops down to that corner. So I'll put the back in heavy now. Okay? Then, now we have to say, okay, this is the front, right? I also have my 67 radiuses. I can come in here and come in here. So what I'll do is I mark 67 in from one corner. Only need it from one corner. So that's 67 marked there, right? And of course it should be directly under that point because that point is in 67 as well. And look at it, it is. So that's perfect. So you get your compass then, and because that point is in 67, you open it out from that point out to the edge like this. Now I'll do this lightly first, right? Right, and I went a bit past it because I have to drop that line down lightly in a minute. Then to get in my 67 here, mark it in like that, and again that would be directly underneath that point. And I draw this lightly. Right, I'm going to bring it just past where I know I'll be dropping it down. Okay? So then, we can come down there until this line hits here lightly, and I bring that across. And that one there will hit that at the same point there, right? So this is, we're beginning to get the outline of the shaded area now, okay? Now, from this point here, which is that point right there, I'll come down my 40, and it's already 40 there to there because we know we've measured that, so that's correct, right? That's your 40, and then in 22. So I'm going to bring this down, pop in 22. I'm going to bring that one down there, pop in 22, and that will get me the 2 points. Now, them 2 points are 62 apart, so is there a need for me to measure into 22 on either side? No, because I have my 62 wide there. So what I do then is project this down here, keeping all this nice and light, and I project this here, right? And the reality is we don't have to draw the line the whole way down. When I mark it up there, all I have to do is mark it there, but it's good to get into the habit of it while we're learning. And I can heavy in this front surface there. Okay, now where do they go then? That one goes back over there, that one goes back over there, right? Because look, this point here, which is 62 wide, the right hand side of it goes to there, which is the corner of our quadrant, which is here. The left hand side goes back to the same corner of the quadrant on that side. So I bring this to there, and this one here back to there. Now I can then heavy in my circles if I want, okay? So I may as well. So again, compass, using the compass accurately is practice, 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 lads. Right? You lean into the direction you're going. Always. So when I'm going this way, I wasn't leaning back and going in that way, I was leaning forward. Right? One hand generally keep the pin where it's supposed to be, nice pressure downward there to the left, swing the other one around nicely. Now, on here then, okay, there is a line, this line here is directly vertically above that point, which means it'll start here, and it goes over to a point that's directly above the corresponding point over there, which is here. So I can heavy that line in there horizontally with my T-square. Okay. Now I still can't fill in this little coloured or shaded rectangle, because that's going to be done over in the end view. Okay. What I can do is this little horizontal surface up here. Okay. What's the width of it? Well, the width of it we know it's that wide, right? Which is 106. Okay. How far back in there does it go? Right? From this view, we don't know what that distance is. I can bring my two lines up a bit. So say I can go up there a light bit, and I can go up there. But I don't know how far I can measure up here before drawing that line at the back in there. Now, where do you think we're going to get that distance? Well, that distance is represented by this line. And where are we going to see that line when we look in the direction of ROB? Right? Now, what we can do up here that we haven't looked at yet, of course, is all this section here. Okay? So, we have the 2 points there, right? The center of our quadrants, right? So what you can do is, you have that point. What's the radius? Well, it's 15. What's the radius out there? 15. Now, what I'll do is simply bring down this edge. And how do I know that that's my radius 15? I know that that's my radius 15 because I measured in 55 at the top. Okay? So when you bring that down there, right? That's that radius 15 there. Right? So you get your compass, it's set now to 15, there to there. You can draw that in heavy. Same, you can bring it over here. And draw that in heavy there. Right? Now, they can be joined lightly, right? Now, I stayed bringing them quadrants till I hit the line coming down there. Right, so that's how you know when to stop the quadrant. Then, now what we need is, we actually have a semicircle now, right? Which is the top of this white surface here, which we've established already is a radius 30. Remember up the elevation I came 30 left and 30 right. So what I can do now is I bring down this point here, right? Which will be 30 from the center there, which I haven't brought the center down yet, so I bring the center down. And now this should be 30, right? And it is. So I now open my compass, and I can draw in this 30 radius. So, okay. Now, obviously, they can be joined with a little horizontal line there and there. There to there, there to there. Now, the rectangle on top here, right? We know the back of it is in line with there, so the back of it lies on that line. We know it's 40 wide, so how far left and right will I come? Obviously 20 mil. 20 mil left and right there then. 20 left, 20 right. Now what's the thickness of that rectangle? How wide is it from the back of it to the front of it? 15 millimeters. Okay. So I mark my 15 millimeters down. Now it's coming quite close to the edge at 15 mil. Right? There. I bring it down here. And I now have back of that done there, front of it there, and the left hand side there, and the right hand side there. Now, is there any more of my plan there that I can do? Alright? At the moment there's not. Okay? The line here, the side of that rectangle, the side of that rectangle are already in likely, right? Because we knew they're in line with them. Right, because we knew we said they were there. Now in my elevation, what could I put in now? Well, this little rectangular hole at the top of it goes down a depth. How far down does it go? 8. Will I see that anywhere? In the elevation, I'll see that as hidden detail. So it's 40 wide, which I have there, so I'll bring the two of them up. I'll drop down 8, and that will be my dotted hidden detail. Because when I look in here, I don't see it, but I know it's there. So I'll bring up the left hand side of that. I'll bring up the right hand side of it. Okay. On the left hand side of it there. Then I'll drop down 8 mil. So that's your 8 mil, and that's dotted. So That's your hidden detail. There's your hidden detail. 8 mil down. Right? Again, I just want to project that. Right? So there's your hidden detail. Now, is there any hidden detail in this one here? No, there's not. Okay? Now that we've our elevation and our plan done as much as we possibly can for the moment, we now have to bring this out so that we can see the spot for our end view. As always, for our end view, right, we bring this point, the furthest bottom left hand point of, or right hand, but in this case it's left, of our elevation. We bring that down to 45 degrees as shown. Now we're going to bring the back of our object will be here, right, because the back is closest to our elevation, and the back is closest to our elevation in both the plan and the end view. Our front will be brought across and up, that'll be our front. The width from the back to the front, from the side of the object, and the distance from the back to the front above the object, they have to be the same. The object doesn't grow or doesn't shrink. So the distance from the back to the front here is 107 mil, the distance from the back to the front here will be 107. That's why we use our 45 degree set square, which is same length either side there. So that means that if I bring them out to 45 and up, they're the same length. If you use your 30 or your 60, you'll be incorrect. If you come down there sharp, it'll get thinner. If you go out there 30, it'll get wider. But 45 means this distance and that distance. They're the exact same. So you're just flipping it over. So the back, brought up lightly here. The front is brought up lightly there. So that's the back, that's the front. Project the two of them up. That's the front of our object. That's the back of our object. Okay? Now, as we look in here on the right hand side, the right hand side is going to be heavy the whole way bottom to top. Right? The line isn't a true length because the bottom point is closer to us, the top one is further away. Because as we look in here, it's sloping away from us. The base, even though it's a curve and a line going away from us, we'll see is 67 plus 40 long, which is the width. So the base line is heavy, all the ways across, and the back right hand side line is heavy, all the ways across. Okay? Now, how heavy in at the top does it come? Okay? Well, it comes in for this quadrant of a circle and then for this semi. So the distance from the back to the front there, which is 45, it's our 30 for our radius here and our 15. Now again, you should do no measurement in this one, really, right? Most of them you have. We have our 45 there, from there to there. I'll bring it down through the center just to know it, so we know exactly where it is, right? There's our center, so from there to there is 45 because it's 15 plus 30. So I bring that over like this, project that up, and that is how far up on the top there that I can come in here. Right, again, I'm going to try to zoom in as much as possible so that you can see as much as possible. Okay? Now, so that comes in heavy here at the top, 45. Right? Then, where does it go? As we look in here, it comes straight down till it hits the surface that's coming down at an angle from this point. Now, how far out is that point do we know? It's out 15. Am I going to measure my 15 out? No. I've already measured it here. So I bring this distance, which is 15, I know that already. Bring that distance over, and then I project it up. So that's out 15. Now where is the point down here that will go down to? Okay? That front surface here, of the shaded surface, will come down along there to this point here, which is how far out? 67 mil out. Okay? Now, am I going to mark the 67 mil, measure it? No, because I've already measured it. This is 67 here. So I just simply bring that line over there and project it up. Okay? So that point joins up to that point. There to there. So this surface here is actually a surface that from the left hand side is curving out towards us till it gets to this line, which is here. Okay? Now, and the front that front point here, which is in 45 at the top as we look in, which we have there, drops straight down to this point. So you're probably getting a sense now that you can see that's going to be the bottom point here in the centre of our freehand curve there. Alright, we'll leave the freehand curve for a moment, we'll finish as much of this as we possibly can. Now, straight up from this point, which I've already got from there, right, or sorry, this one here, straight up from that for a distance of 30, which we've already got here, is this point here. So I'll come straight up from there for 30. Firstly I'll take across me 30, then I'll project up here 30. Then I come down to this point, which is up 12. I have my height here 12, so I'll project that across, and it comes down here. As I look in it comes down to this point, which is 12 up and out on the left hand side. So at this point here, this little line here is going to be heavy. So that's heavy, and that joins back up here. Now, right, and this incidentally here, this is surface S here. Sorry, I marked it there one second. I could pick a colour now to be fantastic. Right, surface S. Right, not a true shape, because this side of it is closer to us as we look in there than that side. Right, now next step. So as we look in here from the right hand side, we see surface S, which we've got, but at the top point, which is up 30, 12 and 18, which we have there, it comes in, and that's a horizontal surface, so it comes in until it cuts this surface again. So I bring that straight in there. Now this little line here is important, because that gives us a distance. Right, what distance does it give us? It gives us the distance from this line to this line as we look down on top of it. Right, so in other words, it gives us the width of this shaded one here. Now we didn't have this down here. Remember we said we know it comes up, but we didn't have how far. So obviously we could measure that with our set square, measure it there. We could measure it with our compass and mark it there. But as usual, we want to be using projection. It's called orthographic projection. So that, bring it down to the line, then bring it across, and that now lets us complete this rectangle here on plan. So I'll project, I'll finish it there to there, there to there, there to there. Okay? The plan is now complete except for this rectangle here. Okay? This shaded rectangle, and again it gives us this 10 measurement. Where do we see that 10? Do we see it in the elevation? No, we don't, right, because it's not a vertical measurement. Do we see it in the plan? No, because it's not a horizontal measurement. The 2 10s there are a measure along this surface. So if it's along that surface, where do we see that surface as a line, so we can mark them 2 10s? And the answer, of course, is we see that surface as the top line on surface S, which we have over here. So over here I'm going to mark up 10, which is there, and then I'm going to mark down 10, which is there. Right, now they're probably a bit big, a bit too a bit more unneat than they should be, or unneat. I did pass English, as you can tell, but I should have put them smaller, but I want you to be able to see them. Right, now what I'm going to do with the 2 of them, right, first of all I now have the height of them as we look at the elevation, because if that's the height of the bottom of the rectangle from the side, that will be the height of the bottom of the rectangle from the front. That's the height of the top of the rectangle from the side, that over here will be the top of the rectangle from the front. So I can now project over the top of the rectangle, and I can project over the bottom of the rectangle. Right? And do we have the width of that rectangle? And we do. Okay? Remember, look, the right hand side is in line with this line, which is here, so that's it. So you can now see, and the left hand side is in line with there. So you can now see the rectangle, so I'll heavy that in there now. Now thankfully, it's only a shaded surface on top of that surface. There's no depth to it, so there's no hidden detail in any of the views like that, because that would make it quite difficult. Right, hidden detail on a horizontal surface or vertical surface is easy enough, but when it's at an angle it can get difficult. Okay? Now we have the width of that already brought down in plan. But where do I get it down here? So how far back from the front of the object is the bottom of the rectangle, and how far from the front of the object is the back of the rectangle? I have the widths. And of course we go back to our 3D picture here. As I look in the side, I get how far back this line is from the front. And as I look in the side of RB, I see how far that line is. So obviously, of course, like with every other every other orthographic question, we're going to project these two down here now and project them across. So you project down the left hand side and you project down the right hand side. Like that. You then project these across, right? And again, I know it's heavy from there to there. So follow that down, and you join them there to there. I know this front one comes down here, comes across, it's heavy there to there. And at the two sides, then I can heavy on the two sides, right? Now, that's my plan fully complete. That's my end view there, fully complete, except for what? What do I see now, looking in this direction here, that I haven't put in? All the surfaces that I see, I've put in. But of course, the hidden detail of this hole at the top, right? Now, how far down is it? How far deep does the hole go from the top of the surface? 8. Am I going to measure down 8? No, because I already have it there. So I'll project that straight across, right? And now I have to get how far from the back of the surface does the hole start, and then what's the width of it. And of course I have the hole here. So this line here, right, that's where the hole starts. This is where it finishes. I haven't brought this across, so I'm going to bring this across. And I'll project that up. Right? And now I have the hidden detail for my hole. So look. Now, so there we have it, right? There's my elevation, plan and end view complete, except for the freehand curve and the elevation. Now, how do we do that? Again, what you have to look at is, you have to look at the question, right? And you have to say, I'm going to get points, right? What points am I going to get? I'm going to get this point and that point, which I of course already have as there and there, right? I'm going to get this bottom one, which I already have here, and I already have here. So to get there, all I'm going to do is project this across, right? So that's the bottom point. So I know my freehand curve is going to come down here and going to go back up there. Now, what other points? Well, you want to find just a couple of points between them, right? As we've spoken about before, the more points you find here, the more accurate this is going to be. But as a standard for junior cert takegraph, the accuracy that we need to use is simple. We use our 30-60 set square to find these points, right? And of course I have the two of them there, right? Now, what I'll do is I'll mark them here, look. I'll mark 1, 2, 3, 4, 5, 6, and 7 up on the left. So as we look in here in the elevation, 1 is the top right, so I'll mark that as point 1. As we look in, 7 is the top left, so I'll mark that as point 7. Okay? The bottom one then, there is point 4, right? So 7, that is 7 here. Okay? This is 1, and that's number 4, right? Then over here, 1 and 7 are there, so that's where 1 and 7 is. As we look in this direction, 1 is there, and then 7 is directly behind it, which you mark as the 1 point because they're directly behind each other in this view. 4 is at the bottom. Now I want to get the other ones, right? So I want to get 2, 3, 5, and 6. Okay? Now, so as we said earlier, we use our 30-60 set square. So come up here. This is the center of the semicircle. Excuse me. So I come out 30. I go 60. And I go 30 or 60 rather down this way, and 30 degrees over to the left. Now, call that point 2, we'll call that point 3, we'll call that point 4. Oh no, geez, that's 4, sorry, that's 5. This one is 6, and that one is 7, right? Sorry for that small technical error there. Hunger is getting to me. Now, so where do we want to find them, right? Them points are all on this shaded surface, right? They're not the ones up at the top there. There would be points directly above them that we'd see at the same spot, right? Up here. We're not worried about that. We're worried about these. So we want to get them up there. So I already have 4, 1, and 7. In the elevation, any point is directly above itself in plan, right? So I bring 6 up like this. I bring 5 up. I bring 3 up, no need to bring 4 because I already have it up, and I bring 2 up. Right? Now, how do I find where they are up here? Well, I want to find a point where they cut into the curve, where they cut into the shaded surface. Do I have that anyway? The answer is I do. Right? In this part where you're a freehand curve, you'll see one of them as a semicircle or an arc here. You'll see the other as the freehand curve, which will be up here. But you see the other as an edge view, which we have here. So, simple enough. 2 and 6 will be on the same line. They go over here. 2 and 6 project up here. Now where they cross there, that's 2 and 6. Right, so there we have 2 and 6. Similarly, 3 and 5. 3 and 5 are projected across there. Then they're projected up. Now where they cut the surface there, there's 3 and 5. Right? Now, which are actually on this side? Okay? Remember, we're looking in here from the right hand side. So as we look in, 1, 2, 3, 1, 2, 3, 4, we'd actually see 1, 2, 3, 4. Then 5, which is there, is around the back of this curved surface. 6 is there around the back of the curved surface. And 7 is directly behind number 1 there. Then, finally, to finish, we come across from 2 and 6. Right? Now, where's the line coming up from 6? And it's here. So that's point 6. And line coming up from 2, that's point 2. This one here is point 3 and 5. So we bring the two of them across. This is point 5, coming across from point 5 there. And this is point 3, coming up there. So now it's going to be a freehand curve to fill this in. Okay? Now again, freehand curve is something that can be practiced, right? By literally just getting an A4 sheet, putting down a few dots on the curve, putting down a few dots on the curve, and just freehanding them in. Okay? Now it is okay, as long as you have a nice light pencil, to do it, first of all, lightly, right? And also, a couple of principles on doing this freehand curve, right? If you can move the sheet around, do. Okay? And also, always bring the pencil, the point of the graphite, back towards your wrist. Alright? So I'm not going this way, away, because your natural movement is back this way. So, go 7, right? 7 down to 6. Right? So keep a bit left now. This is all done really lightly, so. And try to come through 4 without stopping. Now, I'm going to move it a bit now. Okay, try to keep it there where you can see it. Right, so I'm going to start heavying that in now. Now this is, we don't get a second take of this, so hopefully it goes well. I am recording this video again. Oops. Right? So, that is our elevation plan and end view complete as requested in part A, B and C of the question. Okay? Now, read the question again. Draw an elevation in the direction of arrow A. Right? Put a line to that, we've that done. Project a plan from the elevation. We have our plan complete. Project an end view in the direction of arrow B. Done. And as usual, we outlined the 5 different things at the start of the question. Your plan elevation end view, your freehand curve, which we've done, and finally our true shape of a surface, right? Surface S. Now, surface S, I'm going to mark in blue in the different views, okay? So, this is surface up. Jesus, sorry. So this is the bottom of surface S there. That's the bottom of that's the bottom of surface S over here. This is the side. It's the side. 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 And, right. S, and where down in plan is S now, right? Any vertical surface in plan will appear as a line, or sorry, any vertical surface will appear as a line in plan, and in this case this is S here, right? So this is S at the moment. Right? There. Now, we'll index the 4 points. So, we'll do it on the 3D graphic first. So, we'll say the first one is 1, 2 is above that, 3 is back there, and 4 is down there. And we're doing it in blue to keep it separate. If you're doing your pencil, what you can do is you can call that A, B, C, D if it suits. Or else you can, of course, you finished at 7, you can just go 8, 9, 10, 11. I'll do it in blue now, so keep it nice and artistic. Now, looking down on top, I see 2 here, and then 1 underneath it. So this is 2 and 1. Over here, we see 3 here, and 4 is underneath it. So this is 3 and 4. Over here, directly above this is 3 and 4, which is at the top 3, 4. Then at the bottom, 1 and 2. And then over here, on the left hand side, we have 2 and 1, which is higher. 2 is at the top. So that's 2, that's 1. And over here then, this is 4, and that's 3. Okay? So there's our surface S. Now how do we get the true shape of any object? Right? So to get the true shape of any surface or any line, we have to look perpendicular to it. So if I want to get the true shape of an object, if I want to get the true shape of my set square, as you look down there now, that's not the true shape of the set square, because you're not looking perpendicular to it. Now you're looking perpendicular to it, so now you can see the true outline of it. If I come up only the slightest, if I come up literally that much, you're not seeing the true outline of that shape there now. Now you are, because you're looking perpendicular to it. In this question, you know it's a rotation, right? Which one are you going to rotate? The one that you represent as a line. So this one. Now, do we have to rotate from the right or from the left, from either point? Doesn't matter, right? Generally, the fact that there's a load of lines here, I try and put it out here, which means I rotate out here. Okay? Now, right? So, we rotate it till it's out horizontal, so here that goes, right? So bring it out lightly. Now which line will stay the same up here? 3, 4. Because this is like a door now, this is where our hinges are. 1 and 2 are going to swing out. So we're going to swing out there, because I know if it's a horizontal line here, the elevation up here will be me looking in this way, which is perpendicular to my baby finger there. Right? How do I get 1 and 2 out here? Rotate it around. So you get your compass. You rotate 2, 1 out here. And again, the crucial thing is here that it's horizontal here now. Right? So I'm going to mark, I'm going to use a bit of green here. Okay? I'm going to use it dotted. Right? So this point now is 2, 1. Okay? And we're keeping 3, 4 there where they are. Now we project it up. 3 and 4 will stay where they are. 1 and 2 will stay here. The surface S is being hinged open now. Right? So 4 and 2 will stay the exact same, and we cut 1 and 2 and we just opened it out. So I project up 1 and 2. Right? Which point is on the ground? 1. Which point is 12 mil up? How do I know it's 12 mil? Because earlier on the question I knew that was 12 mil up. That's 2. So now this here is point 1, because it's on the ground. That there is point 2. Okay. 4 and 3 stay where they are, because that's where we hinged it around. And then to finish it, right, we'll do dotted. Dotted over here. Horizontal here. And I'll just mark it, that's the true shape of surface S. True shape of S. We have our height of it, we didn't have our true width, we had the width from here. So we just rotated that around and then projected it up to have the width. So that, ladies and gentlemen, is 2016 higher level orthographic question. Okay, and I'm just going to zoom out so you get the whole of it. Now again, the sheet is a bit dirty. I could do it if you have your equipment, you should be cleaning it regularly. right? I use some of the class equipment there, and obviously I could do it, could be neater. Okay, now that's the question done out there. Okay, this here is the marking scheme, just so you know. If you got your elevation done, fine. Altogether it's 21 marks. The plan altogether is 19 marks. The end view is 12, right? And then the true shape is 8, right? So there's 70 altogether, of which 60 is done here. The 10 then, as you're aware, is your accuracy in presentation. Okay? So 20 out of the 60. So 1/3 of this is for the elevation. 19, again, more or less 1/3 of it is for that. And then the end view is 12, right? And then the true shape there, right? So that's that done. I hope you find this informative, and I hope it helps at home. Thanks very much for watching. Until next time.